Hey, welcome back to the lectures. Now let's understand about disassembly feature of the IDE. So what exactly is disassembling the code? If you check the dictionary meaning, disassemble means translate from machine code into higher level programming language. So in our case, disassemble means, so we have a tool called object dump. So we take that tool and we run that on the executable file what we generated, that is .elf file. And we can get back the assembly instructions generated for the program what we have written. This will be helpful when you want to carry out instruction level debugging. So that means if you want to see what are the processor instructions generated for the code you have written, and if you want to understand how exactly the control is passing from one part of the program to another part of the program, and if you want to check whether there is any room for optimization and all, you can do the instruction level debugging using a disassembly feature. So the IDE also gives you disassembly window from which you can observe the instructions generated. So the IDE also does the same. So it also runs object dump tool internally on the ELF file. Let's go to the IDE and let's see how to get the disassembly feature. Now, once you are in the debug mode, so what you have to do is you have to go to Window, Show View, and just click on Disassembly. And here it is. So these are the instructions generated for our code. So all these are ARM instructions, or strictly speaking, these are thumb-2 instructions of ARM instruction set architecture. So please note that the processor what we are using here is ARM Cortex-M4, and the processor architecture is ARM v7E-M. That's the architecture name for the processor. This architecture uses this ISA, that is instruction set architecture, designed by ARM, and the instruction set architecture name is thumb2, which is a collection of 16 and 32 bits instructions. So here you are not seeing this cursor right here. So if you want to get that, what you can do is just click on go to current program counter, so which is right here. All right, so these are the ARM instructions which are generated for our main function. So if you just check our code, so what's happening here? So this is actually a case of read, modify, and write, isn't it? So if you observe the equivalent assembly code here, so these are the assembly mnemonics, and these are the opcodes. And this is a location where the opcode is placed for this instruction mnemonic. So if you just observe this, so this is nothing but the collection of load and store instructions, right? First, the data is read from the memory locations into the processor registers. So by using load instructions. So this is where the read takes place, reading from memory location to the processor registers. After that, this is the modify operation, add. So two registers are added and the result is placed in the register R3. And after that, this is write back to the memory location. Now the content of the R3 is written back to the memory location. So if you are not able to see this opcode, then what you can do is you just right click here and just select this show opcodes. And here you can see that even though we have written only this much of code, the disassembly is showing lots of code, right? Because you have called printf here, which actually includes codes from the standard library. So because our project also uses standard library, right? So you can also check this disassembly using object dump tool on your .elf file. For example, I can run the command arm none eabi obj dump. So just run this command and you can use the argument -d. So that is disassemble, display assembler contents of executable sections. If I run that command -d on my ELF, so here it is. So it disassembles all the code sections and gives you the assembly code generated. So you can see that there are lots of code, isn't it? So even though your program looks very simple, since you have used printf, so all these codes from the standard library are included. So our main code is right here. So this is our main code, and our main code starts at this location in the program memory. And this happens to be the first instruction of our main function. And you can see that most of the instructions are of 16 bits. And since it uses thumb2 instruction set, some instructions also of 32 bits. So for example, this instruction is a 32-bit instruction. So if you want to explore more about thumb2, so please go to the ARM website and explore about the thumb2 instruction set architecture, and the discussion is completely out of the scope of this course. So that's about the disassembly. So use it whenever you want to do instruction level debugging. Let's say I want to debug what exactly is happening at this line of code. So what I would do is I would just put two breakpoints. So one is right here. So just double click over that blue strip and put one more breakpoint right here. So here you can see that at the right hand side in the disassembly window, also there are two breakpoints got inserted, right? Now if I run the code, and you can see that all these instructions actually ran, isn't it? And I got the result. So the result is this much. But if you want to do instruction level debugging of this line, then you have to insert breakpoints in the disassembly window. Let me reset everything. Let's see, I want to see what exactly happens in these two instructions. So I would put a breakpoint here, and then I would run the code. And now let me check the register R2, because that was the affected register, right? R2. Let's check the register R2. Now let's go to the registers R2, and here you can see that. So the value from the data memory is read and placed into the internal register R2. So that is minus 4000. And if you want to see the address, then this is the address. Now let's change the format to hex. So from R3, that is the address. Value is read and placed into R2. And after that, what happens? R3 is loaded with another address. Let's see what is that address. So I'm going to remove this breakpoint, and I'm going to place the breakpoint here, next line, and I'm going to run. And R3 content is now changed to this value, right? To fetch the next value, right? After that, now let me put the breakpoint here. So now let me remove these breakpoints and let's run. And here you can see that now R3 contains 0 cross C8, that is nothing but 200. So now R2 has minus 4000 and R3 has 200. And after that, add is executed. Right, now let me keep a breakpoint here and let's run. You can see that add is executed and the result is placed in the register R3. The result should be written back to the data memory, right, to the variable result. So that's why for that R2 is loaded with the address. You can see that. Let me put the breakpoint here and let's run. And here you can see that R2 is loaded with the address. So this is the address of the variable result. And after that, store is executed. That means value is placed into this memory location, right? So you can see that in the memory location window. Let's go to the memory browser. So this contains 0. Let's execute. And here you can see that the result is placed here. So this is nothing but minus 3800. So that's how you can do instruction level debugging using disassembly. And with that note, I would like to end this video. So try this at your desk and see whether you are able to do all these things or not. And I'll see you in the next lecture.